So our first speaker is a frontiersman. He cuts trails. He fends off wild beasts. He crossed raging rivers and braved freezing winters. He cleared and plowed virgin land. He built log cabins with his bare hands. Metaphorically, of course. Production Clojure and basing a company on it is pretty comfortable now. But someone had to blaze those trails. It was a vast wilderness. And we're glad he did it. Clojure is a nice language to do this stuff in now. But imagine back in 2008. Please welcome our first speaker, Baishampayan Ghose, also known as BG. He co-founded Helpshift, where he built a team of 80 Clojure programmers. Give him a...
So, good morning everyone again. And before I get started, the title of my talk is Revenge of the Pragmatists. I mean, that's what sort of I was setting out on. I wanted to take my revenge on the industry with some practical and pragmatic stuff, which, as you know, is not really common in our industry. So that's some info about me, and I'll get started. Who the hell am I? Well, as Eric mentioned, I got started with Clojure professionally in 2008-2009 when I co-founded one of the first Clojure startups in the world. And I think we were probably the third or fourth company to take Clojure to production. Take a couple of steps back. Before I got started with Clojure, my professional experience was mostly with Common Lisp and Python. By that time, I had already built an air travel booking system and a social network, sports-based social network in Python and Common Lisp for different companies. And I had learned to appreciate the power of Lisp, the beauty of functional programming. And but at the same time, I was bitten multiple times by Immutable state. So I was sort of doing really well in my career, but at the same time, I was extremely dissatisfied with the state of the art, with the tools that we had at our disposal as programmers. And of course, also the overall trend of the industry. So I thought that I would do something differently. Maybe build a totally new company and show the whole world that functional programming is practical and Lisps can be used for building real-world systems. So that's what I got started with. But before that, there were some obstacles. So let me talk a little bit about the nature of business software. If you really look at the business software industry, I'm sure all of you are pretty well acquainted with it. Ultimately, business software is basically an automation of a business process. We are not really trying to invent something or do something really innovative. The most value in businesses is had by automating already understood business processes through software. And of course, those kind of problems are very heavily data processing oriented. So you take data from random places, process it, and then send it away. Potentially, it's a high throughput sort of a system. So you will have lots of users, but it's not necessarily a real-time system. And that too, with high throughput, not many companies get to the stage where they need to even deal with high throughput traffic. And of course, you will be dealing with multiple database technologies. You will have probably the traditional RDBMS and maybe the newfangled NoSQL stuff, maybe some graph databases, some OLAP databases. So you will have to work with all these different data sources and pull the data and do a lot of processing. And it's most probably cloud deployed. We don't really deliver software to desktops anymore as much these days. most business software is delivered through the cloud. And requirements are constantly changing, right? It's not that, oh, okay, we need to write a compiler for a specific language. It's not that. It's always some fuzzy sort of business requirements which keep on changing every week. And of course, it's all held together with duct tape. If you really look at serious software, like software that IRS uses, I heard that it's written in assembly language. So just imagine that millions of people are using software which is written in an assembly language which is unmaintainable today and very hard to upgrade. So that's the sort of the status quo. That was the situation. And for that kind of a problem domain, I needed a different language. I needed a language, of course, I needed Clojure, but at that time I didn't know. I thought that I needed a language with list-like semantics. I want my language to be dynamically typed. The static typing, I feel, sort of always comes in the way of experimentation with data, especially. And also static typing type languages can't really offer a really first-class REPL experience, which I had learned to rely on. I needed first-class functions. Of course, who can do without first-class functions today? You need a good library ecosystem, definitely. You don't need 20 libraries for every problem, but you need at least one or two of them. And immutable data structures. From my prior experiences, I had realized that I would not seriously consider any programming language where mutable data structures are the default. Because even though you, as a programmer, have a lot of discipline and you write code the right way and avoid mutation, you can't guarantee the same thing about your coworkers or some third-party software that you pull in as a library. But at the end of the day, I really wanted the language to get out of my way. Okay? I wanted a tool which would help me solve problems. Sort of, I use the term software development at the speed of thought. That's what I want to do. Like, if I have figured out in my mind a conceptual model of the problem and the solution, going from that conceptual model to executable code, that path should be really short. I should not, or I need not deal with bureaucracy in a language, like classes, interfaces, all these design patterns, stuff like that. So I was looking at that time, and then I discovered Clojure. And mind you, at that time I was a smart list weenie, as they say. And I looked at the J in Clojure and I ran away right away. I said, oh, it's got something to do with Java, and it seems to be yet another Lisp dialect. Who cares? I know Lisp. I ran away. But later, I think in a few months, I looked at it again, and I realized some amazing stuff there. Clojure as a language seemed to be extremely well designed and well thought out. And it also seemed to be designed by a practitioner like me, who is not scared of reading papers. So that sort of was very comforting. And I read the whole compiler source code, I remember back then. And because I tried to understand what's going on there. And I read the source code and I understood it. And that was a light bulb moment for me, because I had never looked at the compiler of Python or Lisp or any other compiler for that matter, because those compilers or runtimes are not as accessible as Clojure is. And the community, I think back then the channel probably had 50 people in it. And but even then, the community was a very, very warm and welcoming community, and it was full of people who were really experienced. They were far more experienced than me, and they were looking at Clojure. So that also gave me a lot of motivation and comfort and confidence. And also, hey, I mean, Clojure is a Lisp. I loved Common Lisp. I loved the scheme, but there were challenges, especially especially with common Lisp, the mutable data structures, and also the language itself is so complex that sometimes you think of Lisp being sort of a problem and not really an enabler. So yeah, it seemed to me that it had all the best qualities of Lisp, but at least most of the bad ones were not there. And it was very well thought out, very clearly designed. And the JVM, I learned to appreciate the JVM far better after looking at Clojure, because then I was able to look at the JVM without Java, right? And it's very important for us to consider the JVM as a platform and not just a programming language runtime. So I was happy, right? And I really liked Clojure, and I thought that we should do it. But there were still some risks. It was a risky bet, even then. It was less than 1 year old. And, you know, anything could happen. The community could implode over time, or the creator of the language may take some strange decisions which may break the language, or maybe it may become proprietary overnight. There were so many challenges. There was no tooling. I remember writing Ant build scripts by hand at that time, because again, I did not have any serious Java experience, so I was not really experienced about the Java ecosystem. I was not an Eclipse user, I've been an Emacs user all my life. So I didn't know how to generate XML, or if there are any buttons that you could click to generate that build script. So I wrote it by hand by reading the documentation. And that's how we got started building Clojure. Yeah, and of course, Clojure back then did not have all the powerful features that we take for granted today. It didn't have protocols back then. And all the cool things that have come out in the last few years, none of them were there. However, I felt even then that the language was complete. I did not feel that this language was lacking any critical feature or something that would impede me from achieving my goals. And I felt that even if something is not there, I could write it myself. And yes, definitely we did reinvent a lot of libraries that we know about today in the open source Clojure world internally, because our staff predated those things. Like we have an internal implementation of prismatic schema. We wrote it 2 years before schema came. We had implementations of our own drivers of talking to databases. We even contributed to lots of open source Clojure libraries because of that. And we had to fix so many bugs in so many tooling libraries. We had to fix issues with device driver, database drivers and stuff like that. But yeah, and of course, a lot of people said that it's a Lisp, so it's very risky. Lisp is only used by scientists and academic people. It's not used in production, all these kind of stuff. But I did not have any problems with that because I had already built a production system in Lisp. So no one could give me that spiel, and I would not accept it. So I was completely convinced about going forward and investing in Clojure. But there was a bigger problem. The bigger problem is this, that how do you convince business owners? How do you convince your CEO to use Clojure? Because as the CTO, you are optimizing for certain constraints. But as the business head, the CEO is optimizing for some other entirely different constraints. In this case, it is about risk mitigation and not really gaining any leverage through any programming language. No business founder or business owner today is worried about using the best language available to build their software. They are thinking about taking the least risky path, right? Because, and let's be honest, they have different things to worry about. I think as engineers, we often overlook the cultural and the people aspects of software development. And hence we think only in terms of just software and tools, and sometimes we miss the bigger picture. So how do you really convince business owners to use Clojure or any new technology for that matter? Well, these are some of the things that may work for business owners. It's very easy to hire engineers. Like if it's Java or PHP, no one will get fired for picking Java or PHP, right? Because it's apparently easy to hire Java and PHP programmers. I don't know where they are, because I've never met many good Java or PHP programmers myself. So I don't know. Or maybe industry reports, like there are all these indices that come out every few months, or some radar white paper or whatever, right? So if your language comes up on one of those white papers, then okay, then you can say that you can maybe invest in that language, or maybe it's ready for prime time. Blog posts from competition. If you see your competition is using some new tool or some other tool, then suddenly overnight that tool becomes legit, right? Overnight, like Node.js. And the moment some competition started using it, I'll also think about using it, because again, the risk is sort of mitigated because my competition is also using it, right? Or hacker news frenzy, like if people are talking about this tool or language or whatever database for that matter on hacker news, and people are going crazy over that technology, suddenly that technology again becomes acceptable. But Clojure didn't have any of those things. We didn't have developers who already knew Clojure. We didn't have any industry reports talking about the power of Clojure. And of course, there were not many articles or blog posts. People are not really talking about it. But what really worked, especially in my case, was sort of the authority that I had over building similar systems before, and also the responsibility that I was willing to shoulder. Because I had to basically do everything myself, because I could not rely on the recruiter to recruit Clojure programmers, because there are none. For example, I could not rely on some trainer to come and train my engineers. I could not rely on someone to write documentation. Everything had to be done by hand, as Eric mentioned. So, another code, right? So sometimes, even if you want to fix just one thing, you may need to fix the whole thing. And sometimes it also may mean building that whole thing, just to fix that one small thing, right? And at least in my case, that was sort of what kind of happened. So, okay, company has been formed, we have decided to use Clojure, right? I've got the approval from investors, from our CEO. What to do next? Well, you recruit a team, you build a team, right? But there are challenges there as well. Well, who do you recruit and how? I mean, junior people don't know much. They don't know what they need to know. Mid-level engineers, they may have some idea, but they just don't know how. And the senior people, they're not interested. And again, I'm speaking in a lot of generality here, based on my personal experience. Yours can be very different. But that's what I have observed, that as career programmers, we don't really think of ourselves as athletes. We think of ourselves as accountants, right? Because an athlete would be practicing every day. An athlete would be investing in having the best shoe that's available in the market. An athlete would always think about optimizing their diet, their exercise, even the aerodynamics of their clothes. But as programmers, we behave sort of like accountants, where we have already learned some rules or archaic technology, or we have some domain knowledge, and we just sit on it. We keep doing the same thing over and over again. So that, I feel, needs to change in the industry. So to to get started with what we did was to target sort of the middle tier of people who had some experience, they had some professional experience, they had seen how the industry works, they have some idea that, hey, even if you use static typing, doesn't mean you will not have bugs, for example. Or, Java may be industrially accepted, but may not be the best tool for everything. Or maybe, C for that matter, anything. So they already had some experience, and all that experience was in the imperative world. Like a lot of people say that, hey, I know 5 languages. I know Java, I know C++, I know Perl, I know PHP, I know C. And then I told that person that, hey, you only know 1 language. That they are more similar than different. It's like a bunch of cars on the freeway. If you look at it from a macro perspective, all of the cars are more similar than different, really. So programming languages also are just like that. And we really had to hammer this idea home that there is an entirely different world where people are thinking about computation in an entirely different way, and it may make sense to consider that as an option, as a potential solution. So while hiring, what mattered for us? Well, degrees, colleges, years of experience with some technology did not matter. I mean, that's what you would read in resumes today, right? That, hey, I'm from this college, I did this major, I have 20 years of experience in Ruby on Rails. Those things don't really matter because, I mean, I have 35 years of experience of addition. Does it even mean anything? It doesn't mean much. But what really matters is your grasp over fundamentals. Are you able to take addition and derive multiplication out of it, for example? Right? So you need to have good fundamentals. Good fundamentals doesn't have to be any language specific. It may mean just having a good aptitude for abstract concepts and abstract thinking. Passion to do better, right? That's important. Otherwise, you will be an accountant. Humility to accept feedback, because I think that is another problem that we have in our community, that we are not humble enough. We think that we know everything because we read Hacker News. But the world doesn't revolve around Hacker News, right? It doesn't. And patience to keep practicing, right? As I said, it's like being an athlete. We don't practice at all, and that's such a shame. We don't have any ethos or habit of practicing programming every day or every week. We just go to our jobs and perform. Right? It's like saying that I'm chilling all the time, just call me when Olympics starts. Right? And I'll go and run. You're not going to win. You may run, but you won't win. And culture fit. I think we often overestimate technical fit and underestimate cultural fit. What do I even mean by that? Well, in a company, when you are building something together, some people will have to work together. For that, there will have to be some overarching ideas which will unite everything. And that is sort of, you can say, is sort of a culture. And if someone does not subscribe to that worldview, then it doesn't matter how skilled or talented this person is, there will be problems in the future. So culture fit is really, really important. And the last one is more of a challenge than a point to discuss. Recruiting, this kind of recruiting works really well when you do it in a sustained manner. Like, you are hiring people whenever you need them, right? So if I met 5 people today and they're all awesome, I'll maybe hire all of them because I don't know if I'll get them later, right? And that's That's something you can do. Or maybe you are hiring just one person a month, or maybe few months you will not hire anyone. That's also okay. So when you are growing a company, even really small, I think the sustained hiring thing works really well. At least it worked out well in my case. But once you have grown, you can't do that kind of hiring. You have to do hiring in burst mode. Someone will come and say that we need 20 Clojure programmers tomorrow. Then what do you do? So that sort of becomes a challenge. I think it's much less of a challenge now because, hey, we are having a Clojure conference here in New Orleans, and there are Clojure conferences happening in Europe, in India, all over. So the Clojure community is growing, and we have a lot more senior developers now in the community. So that problem is relatively mitigated, I feel, but it still exists, especially when you are looking for good people and talented and experienced people. So, but ultimately, it boils down to this, right? That you don't really hire teams, you grow them. Because we have this sort of a mercenary culture in the industry, that it's like everyone is a hired gun, right? They are all like this wild, wild west sort of a thing, that you have, instead of mark shots, you have problems, and there's some bounty hunter will solve that problem, and they will get the money, and then they will go. You don't build teams like that. A team is much more than a bunch of hired hands. A team has connections with each other much beyond, way beyond just the work, right? So how do you grow a team then? Once you have assembled a bunch of individuals who you think are capable of being a part of a team, how do you grow them? Training, right? And I talked about fundamentals, right? If someone doesn't have the right fundamentals, ask them to read the book. The book. And we are so, I think, grateful today to have the two of the authors of the book here with us. And it's amazing. So, this book changed my life in 2003, I think. Yeah, it's been 15 years now. It changed my life because I was doing Emacs at that time. And the Emacs had Emacs Lisp, and somehow I heard about Scheme, and somehow I chanced upon this book, and it completely blew my mind. And it gave me the perspective which I value even today. I think it has shaped not just my career, but even my philosophy around software. So start with the book. So what we did was we conducted workshops, internal workshops, onboarding boot camps, did a lot of mentoring, recommended the book to not only people who were already hired, but people I met randomly in conferences and events. I recommended the book to them. They read the book and then came and joined me 6 months later. That's how it sort of happened as well. Someone was tweeting around, they wanted to learn Common Lisp and were asking for a Common Lisp book. And that guy came to meet me, and I sat with him, and I handed him SICP. And he became a Clojure programmer, and he's a professional programmer. He worked with me for 4 years. So it's great. And if anyone here has not read or checked out this book, please do yourself a favor and buy a copy on your way out of New Orleans. You can get it signed by Professor Sassman. Conferences and community building exercises, very important. When we got started, I attended the first few Clojure conferences in the East Coast. And the first ever Clojure conference, I was there. And it was incredible to meet people who were starting to learn or try out a new language. Right? It was incredible to meet Rich Hickey, David Nolan, and all the old timers in the Clojure community. And later we organized a Clojure conference in India as well. Zach Kellman was there this year too. give the keynote. This was the second year in India. And we also started a conference on functional programming. So that was in its 4th year this year. And that covers all languages, all domains in functional programming. So that really helped a lot, I think. And then book reading groups and meetups. So ultimately what we were trying to do was to really do the cultivation and the growing and not the, the harvesting. Because we had to sow the seeds so that we could harvest later. And I think especially when you're getting started or when a community is really young, you need to do that make that kind of investment. The Java community doesn't need that today, but maybe it needed it many, many years ago, and some did that stewardship. So in case of Clojure also, I think we as a community, we have to take the charge. So that was training. But how do you scale training? You scale training with culture. One way of looking at culture is it's sort of like a scalable training process with feedback mechanism, right? And another way of looking at culture is that if two people are having a conflict, you go to culture to resolve that conflict. And that culture can be around anything. It can be technical culture, non-technical culture, it doesn't matter. Because conflicts happen in life. And what we need to do is to have a clearly codified sort of guidelines which will become or behave like the arbiter in these kind of situations. And so here I'm talking specifically around technical culture and something that is well suited for Clojure. So we built our culture through repeatable processes and by applying them with a lot of rigor. Code reviews, the most important thing, because imagine this, there are 2 Clojure programmers in the company, one person knows little bit, another person is very new, right? What do? Well, you have to have code reviews in those cases. Or let's say when you are onboarding new people, to make sure that everyone writes code the right way, the same way, or maybe in a consistent manner, using the right idioms, using the right best practices. Code review, I feel, is essential. Upfront design, that's something which is very unique to, I think, sort of the Clojure community or the Clojure language, because it promotes a lot of design before the actual coding process. So generally programmers are not really used to that kind of a style of programming. What programmers usually do these days is something that I call debugger driven development, which is write one line of code and get into the debug. And then just keep inspecting your runtime and variables and all of that, and somehow you evolve your software. We can't do that in Clojure. We can, it has the REPL, but it doesn't have side effects and stuff like that. So it's not really easy to do it that way. And also in Clojure, we put a lot of emphasis on the data, right? If you know the shape of the data, then you know which functions you can apply on the data to convert it to your required format. And that's pretty much all programming is all about. So we did a lot of upfront design exercises. We made that a part of our habit. We made sure that no line of code gets written without proper design document that is vetted by the team. Sort of, I would say, modeled on top of how Clojure itself is developed, right? And then of course, style guides, linter tools, we have to use those things because as a team sort of scales, people bring their own taste, their own style, and sometimes that is acceptable, it's admissible, but sometimes it may add a lot of complexity to your code base, so you don't want that. So that needs to be enforced using build pipelines and code reviews and tools like Eastwood and all of that, like Kibit, that kind of stuff. And of course, I think the last thing is very important. back then we had the problem of not having libraries. Today we have a problem of having many libraries for all kinds of stuff, which is sort of, I think, a good problem to have also. But I feel the middle ground here in some way will be to figure out if we can make this process of choosing the right library easier. So internally, inside our company, we just standardized certain libraries and we wrote our own as well. Sometimes some open source library superseded or replaced in an internal library, that also happened. But we had our own internal sort of list of tools that we were allowed to use, and that also I think helped because the developer could not arbitrarily pull in some random library and use it in production. And that helped with the consistency part as well. And because as the Clojure language grew, it got a lot of features. Like we got transducers, we got protocols, we got few other things. And so then suddenly you could write Clojure code in multiple ways. The core library also increased in size. So you could use the threading macro or not, for example, right? Or you could use multi-methods instead of using protocols. So in those cases, I think that's where sort of some mentoring and guidance and some guidelines helped. But ultimately what we really wanted to do was to make sure that engineers can decide for themselves. And for that, you really had to explain the idea behind these features, which is not very hard with Clojure, because with Clojure most features are very well thought out, and there is always some sort of rationale behind it. And so whenever Clojure would come up with a new feature, we would do internal tech talks, and we would discuss those features, and we would also brainstorm about where we could potentially apply this feature. And maybe someone will do some experimentation. But we have always sort of stayed far behind the Clojure release schedule. I mean, I know there are some people who run Clojure alphas in production. That speaks volumes of the quality of Clojure. But we have traditionally been 3-4 years behind sometimes. Clojure, like, we were running Clojure 1.6 or I think 5 for quite a long time. For a few years at least. And that didn't cause us any problems either. That also tells you how awesome the Clojure implementation is, because we were using all the new libraries, but the language never caused us any problems. So that was about culture. Another thing, right? So at scale, all problems become people problems. Because ultimately, let's think about this for a second. Let's consider this. We are building software for people, for human beings. And the last time I checked, software was still being written by human beings as well. So human beings doing something for other human beings. So software is just incidental, if you really think about it. It's sort of bridging a gap between two populations of human beings. So that definitely or obviously cannot be the main focus. So if your problems are people problems, the solutions are not technical solutions. They are also people solutions, right? So you solve them with people, right? So I just wanted to add this line because I wanted to emphasize the fact that when we talk about culture, we speak mostly about technical culture and not the overarching culture of the organization. I personally feel that the overarching culture of any organization is more important than the technical culture, because the technical culture will be dictated by the overarching culture of the organization. Okay. Some of the challenges we faced. Yeah, so I talked about that. So Clojure demands upfront design, and that was a problem with project managers. Because they could see that, hey, you're coming up with 100 lines of code, so why did that take 3 days? Right? Because You can't easily justify that, hey, I was doing hammer-driven development. Because this concept of hammer-driven development doesn't even register in many people's minds. What I mean by that is that Clojure expects you to get away from the computer when you are faced with a problem. So when you have a problem, shut down your computer and get to a comfy place where you can think about your problem and the solution. So that definitely caused issues, some issues, not a lot of big issues, but it was a sort of a perception thing, right? That, hey, Clojure was supposed to make you faster, but you are thinking so much, you are taking so much time in design. Why? Well, no one asked that question that once the software was built, didn't have serious bugs. And sometimes lack of good or well-tested, production-tested libraries did cause us problems in the sense that we were never, it was not a big hindrance. We could always write anything that we wanted or needed, but it was a matter of time, right? So in case of a startup, time is of real essence, and you want to get something out into the market as soon as possible. But sometimes that may not be possible because there is no built-in library that you can pull in. You may need to write it yourself. So that caused problems. And even though Clojure, the language, never ever caused any problems from it. We never had any language-related issue. Some people may have had that, but we built this serious understanding about the semantics of Clojure, so that we didn't have serious problems with the language. But there were some incidental problems around the runtime. Like some of them were around GC. So again, any large JVM software product will have those issues. Memory leaks, sometimes that also happens. In Clojure it may happen if you hold on to the head, so don't do that. Laziness can also sometimes bite you, so please be careful about wrapping lots of lazy functions on top of each other. So, if you're doing that, maybe sometimes realize it, and that will prevent any stack overflows from happening in production. So that happens. And the last thing I think was a challenge, was a personal challenge for me, was championing change. Change management is not easy at all. So what I could do with Clojure, I failed to do with Clojure script. So by the time Clojure script was ready for the prime time, our JavaScript code base had already moved on. And we had hundreds and thousands of lines of JavaScript code, and lots of JavaScript programmers. And for me, it was super hard to champion a shift to Clojure script, so I did not even go there. But maybe something that I think now you can get started with Clojure and Clojure script. We could not do that back then. But that was definitely a challenge for me. Some lessons learned. Some of these things are very well known already. Small dedicated teams with powerful tools can achieve a lot in short time. Functional programming does help in building reliable software. It definitely does. There is no question about it. I have had multiple experiences by now. So never had any memory corruption. So we had only two kinds of bugs in our software system. Only two kinds. One was some business logic was implemented incorrectly or incompletely. Or the third kind happened when we achieved big scale. Those are problems around distributed systems. Can't really be solved within Clojure. But yeah, maybe it requires some discipline, but that's all we can do about it. And most problems, as I said, are around data processing, and functional programming is ideally suited for data processing. So most business applications can be built with Clojure without any problems, And software estimation is still hard. I mean, we find it so difficult to figure out how long it's going to take us to build any software. And more so now with microservices and distributed systems and cloud, there are so many constraints and variables that we don't even take into account when we go about designing our software or doing estimation on the effort. So that's definitely a challenge. And with all the layers of abstraction that we are building on top of our systems, which are also leaky abstractions, which are also brittle abstractions, it's gonna get, I think, harder over time. And yeah, last but not the least, must try Clojure script, something I regret not doing, but I have done enough hobby programming in Clojure script to know and understand the value of it. Maybe next time. Some of the things that Clojure made me do in production that generally programmers don't get to do or don't think that they can do or they don't even get to know about these things. Parsers, interpreters, compilers built into a solid business application. Imagine that instead of a kingdom of nouns and hierarchy of objects, you have actual parsers which are parsing input data. You have compilers which are compiling things to different output, or you have interpreters which are doing it in runtime. And lockless memory, lockless concurrency. Highly concurrent systems can be built in Clojure without using a single lock because of the abstractions that Clojure provides. Monadic patterns, we sort of discovered them in our code. We never used monads. We did not use them, but we discovered the design patterns in our code. And it was great to understand it from that perspective. And immutable data structures everywhere. Imagine the beauty of that. So amazing. And also we were able to wield the power of the JVM. And I think without all the headache of Java. So I think that was great. Some big wins. So some info about, so was able to assemble an amazing team, 100 plus people, majority of them Clojure programmers. All in India, by the way. And we raised $40 million. The product that we have built, the SDK, is installed on more than 2 billion devices worldwide. And the company went on to having 600 million plus monthly active users. And our system, last time I checked, was serving 50,000 requests per second. And multi-data center, multi-tenant, SaaS, 400,000 lines of Clojure. And the largest repository has around 250K. And we also have 200K lines of JavaScript on top of that, extra. So I think that count would have been far less if we were using Clojure script. So Paul Graham, in his article, Revenge of the Nerds, he talked about using Common Lisp to build his company. In case of Clojure, Clojure is not for nerds, it's for pragmatists. That's why I call this talk the Revenge of the Pragmatists. So I feel that Clojure is the ideal language for pragmatist programmers with deadlines. I think I have 2 more minutes. Some parting thoughts. I'll go through them very quickly. Building software is unnecessarily difficult. Does it really have to be that way? As programmers, we should think about it seriously. And distributed systems is also equal to distributed problems. So that means monitoring, better sort of insights into your systems, better metrics and tooling. And Clojure is a language for building processes. Do we have a language for building systems? Because Rich Hickey gave a talk about this a few years ago. We are not really building programs anymore. We are building systems. Clojure is great for building programs, processes, but we, I think, need a language to be able to define a system. And developers need to learn ethics. Incredibly important. I think we start with programming when we go to college. that's great, but I think we should end with an ethics class. Because programmers have more and more power in their hands right now, and without any sort of ethical or moral guideline, it can cause problems. And last but not the least, I think Clojure will always remain a niche language. It will probably never be the #1 ranked language in the world. But does it really matter? Hey, we are having fun here today, right? Anyway, last slide is this. Let's stop coding. We have done enough of coding. Let's build software. Thank you.
All right, thank you. That was a great talk. It just is so surprising that as a startup, you are able to train people and like consistently build Clojure programmers. How did you do that? What were the, just time-wise, I've worked in startups where we want someone who can just start tomorrow.
Yeah.
And there's almost no time to even talk.
Right.
It's just like, just get to work, start coding these features.
Right. I think it depends on the kind of company and startup and time and space. When we got started, we had an idea about building a company, but we didn't know what to build at that time.
Okay.
So we had, I think, around 6 months to a year of time to figure out what to build. And while we were figuring out what to build, we were also building. And that happened in Clojure. That sort of helped us bootstrap the team as well while we figure out what to build.
Right.
So that, I think, was a lucky coincidence.
Okay, cool. Cool. Okay, so you mentioned something about, so a cool metaphor about athletes versus accountants. But then you also said that we don't work enough as a team, or we don't build a team. So I was wondering if there isn't some kind of conflict between those two?
No, it's a relay sport, right?
Okay.
It's a hurdle. It's like that. So you have the baton, so there is teamwork involved.
Okay.
And then you have individual performance as well.
Right, right. So do you think companies should pay because I think of a sports team, the team pays the athletes to train. And then they perform on Sunday night football, whatever.
Absolutely. I think what we have, the setup that we have is that we only have competitions with prize money. Mm-hmm. And that's all, and no training facilities or no incentive for training.
Right.
So I think programmers should also think about getting agents. Maybe that will help.
Right, but so then that again is more like the sort of free agent where you just go from team to team and play.
Right.
Do you think that programmers should get higher salaries if that happens?
I mean, I think we can demand higher salaries as long as we are getting better. Right? So if you can show and prove that you have improved and you have less bugs in your code, why will someone not pay you more? I don't see any reason.
Yeah, so I had another question. Do you mentioned something like you haven't met that many good Java programmers or something like that. And I mean, I know what you mean. It's like nothing against Java programmers.
No.
It's just, there's so many Java programmers that you have this huge curve of they could be really good, they could be really bad. So do you think hiring Clojure and basing your company on Clojure, do you think that it gives you a hiring advantage?
Oh, it definitely does in some way. But it also does limit your pool to people who are interested in learning those things. Right. But it definitely does. That's what Paul Graham also talked about in his article, that it does give you a competitive advantage because someone else can't just come and poach your teammates. But they may still get poached for skills which are transferable. Which are, once you learn Clojure, any other language is nothing.
All right, so this is a really good question. If you could write your names on the cards when you do a question, that would be nice. We could shout you out. So people in the Clojure community, people talk about it being very philosophical and theoretical and like high level. So do you think that makes companies scared that we're just philosophers and not practical?
Definitely does make companies scared, but that's also because it's not really an accepted norm in the industry, right? If you look at other programming languages, I won't name them, but they don't have that kind of a culture.
Right.
And those guys are always writing blog posts like crazy, right? So you see a lot of noise coming from a specific cohort of people who don't care two hoots about reading papers. So, what do you do about that? But I personally feel that as the Clojure community grows, Clojure anyway has huge influence over other communities, and other communities have also started reading papers now. That's great. Over time, I think it will change. And also, as programmers, we must take ourselves seriously. Just because someone says that you should not read paper, doesn't mean I should not, right?
Right. So this is, again, no name, I would shout it out, but so you talked a lot about difficult problems like distributed systems and scaling and stuff. Do you think some companies don't have a problem that Clojure is good at solving?
Yeah.
Like that they don't need something as powerful as Clojure?
Sure, or they need something more powerful.
Okay.
Or they need something less powerful, right? For example, some people may need assembly, and assembly is potentially way more powerful than Clojure, in the sense that you can cause more harm. And or maybe you are developing a game and you have very specific requirements around interacting with specific hardware. So it's not just about power, I think it's more about the applicability of the language.
Right.
And Clojure is a general purpose language.
Right.
So wherever a general purpose language will fit, Clojure will fit just right.
Great. So related question, have you ever found it hard, with this like awesome language that we have, that the programmers get kind of dazzled by it and they don't focus on the practical, that they're maybe trying to create a distributed system when they don't need one? And that
Very
kind of
good.
thing?
Yeah, absolutely, it's happening. But I would say that programmers get dazzled by shiny stuff anyway. So they would rather get dazzled by something that's really good than something which is worthless.
Okay, another question. Why do you think, you mentioned design up front and how it scares business people because you're not working, I guess.
Yeah.
It looks like you're not working. What do you think it is about Clojure that encourages that?
Well, when I got started with Clojure, I had no experience with Java. Today, I can say that I understand Java better than most Java programs. Why is that the case? Because Clojure lays everything bare upfront in front of you for you to understand and then pick out the pieces that you need, right? So I personally feel that Clojure sort of forces you to ask these questions. And then there is also material always there, and that you can go and read. And also the Clojure community as a whole, and Clojure's creator, Rich Hickey, being a leader, has also sort of, I think...
with the hammock talk.
Yes.
Right. And so you're saying it's like, Clojure gives you all these, even on the JVM, which is a monolithic thing, it gives you like the Legos of the JVM. So you have to be a designer. You have to want to put them together in a certain way.
Right.
So, about that, you talked about, people being worried about the design up front, but then they never consider the cost of bugs later.
Yeah. Because it's a perception problem. People are okay if there are bugs in production, but they want to deploy faster still.
Right.
So I think it's just a matter of perception, and it's not a matter of losing resources.
But then there's the bugs you never see.
Yeah.
There's no way to compare.
Exactly.
Like, we avoided 1 million bugs just by using an atom. And
Exactly. So it's very hard to justify that to a non-technical audience.
Right.
They will say that, hey, 100 bugs I could have written, but I have not.
Right.
It doesn't make sense in their mind.
Right.
Why would you have written those 100 bugs?
But it's the same thing as like lines of code. Look, my solution, I only wrote 20 lines of code and I solved. Whereas this other programmer wrote 300 lines of code. They look like they're working hard.
Exactly.
Yeah. Do you think that that's a problem with like the kind of accounting we do and some of the agile practices? where we have velocity, but then the bugs don't count against the velocity of the tickets.
I think Agile is anyway dead. It's agility that I think will live on.
Okay, good answer. Good answer. Any last questions? No? I can't really see.
No questions. So anyway, guys, I'll be available. Please.
We'll be here all day.
Yeah, and tomorrow as well. So please feel free to pick me up. Thank you.
Thank you so much.